In this lesson, we're going to compare numbers that are in scientific notation, and when they aren't, we're going to put them in scientific notation to compare. So let's review very quickly the last three problems from the previous page. So we're going to do 27 times 10 to the 6th, and we're going to put that into scientific notation. So this is not in scientific notation because this first factor, 27, has to be between 1 and 10, which it's not. Right now, the decimal point is after the 7, so I'm going to put it in there. And this exponent of 6 tells us we take the decimal point where it is, and we move it 6 spaces to the right. Now, I'm going to put an arrow showing that I want to move this decimal point 6 spaces right. I'm not going to actually do that, though, because I'm trying to put it in scientific notation, so I want the decimal point to be between the 2 and the 7. And since I want it to be there, the same number would have to move an extra 1. So I have to move it actually 7 times to be in the same spot. So this number in scientific notation is 2.7, so that the first number is between 1 and 10. We multiply by a power of 10, and the exponent is how many times we move it. The red arrow told us we needed to move it 6 times, but the blue part says we have to move it actually 1 more than that, which is 7 times. So the exponent is now 7. Let's do the middle example, and for space purposes, I'm going to copy it down here. 0.03 times 10 to the negative 4th power means that I would take this decimal point that exists there, and I'm going to move it 4 spaces, and since it's negative, I'm going to move it to the left 4 spaces. So I'm going to draw my arrow saying I need to move this left 4 times. But, again, my objective is to put it in scientific notation. So for this to be in scientific notation, the decimal point has to be on the other side of the 3. So here, to get it to be the same spot, I have to move it 2 more times. So my number in scientific notation is going to be 3 times 10 to a power, and the power is this negative 4 that existed, that's the red part, and then I have to go 2 more times, so that's actually a total of 6 times I have to move it, so it's to the negative 6. Alright, let's do that last one there, 527 times 10 to the 15th power. I'm going to copy that one down here so we can all see it better. 527 times 10 to the 15th means I take the decimal point where it is, which means it's right here at the end, and I'm going to move it 15 times. The 15 is positive, so I need to move it 15 times to the right. In order for this to be in scientific notation, I need to put the decimal point between the 5 and the 2, so it's 5.27. I am multiplying by 10 to a power, and the power was 15 here, but I needed to move it 2 more times to put it in scientific notation. So 2 more times would be 10 to the 17th power. So it's 5.27 times 10 to the 17th power. We will be doing more practice with that, if need be. Let's go ahead and take a look at the notes for today. So we're comparing numbers when they're written in scientific notation. If the powers are the same, then all we have to do is compare the first factors. So in this example, the powers are the same, so we simply compare the first factors. Remember that in order to compare, if you have a difficult time comparing numbers with decimals, you should have the same number of spaces after the decimals to compare. So this is 4.60 and this is 4.06. So you can think of it like 60 compared to 6. 60 is bigger. So that means that 4.6 times 10 to the 5th is greater than 4.06 times 10 to the 5th. Now, when the powers are different, so 10 to the 7th and 10 to the 5th, we do not look at the first factors. Those don't matter. What matters is the exponents. Here we're moving it the decimal point 7 times. Here we're moving it 5 times. So as long as they're in scientific notation and the exponents are different, you only have to compare the exponents. So since 7 is bigger than 5, that means that 3.4 times 10 to the 7th is greater than 8.9 times 10 to the 5th. Now, again, don't look at the first factors, because if you did, you would say 3.4 is less than 8.9. We need to look at the exponents. Now, when the powers are different, but they're not in scientific notation. So if you look at this example, 3.4 times 10 to the 7th matches all of our rules for scientific notation. But 0.34 times 10 to the 9th does not. So our job is to convert, so both of them have the same power of 10, and then we compare the first factors. So that's one option. The other option is to put them both in scientific notation. So let's write that down. We can, or put both in scientific notation. Okay, so I'm going to show you both ways. The first way says convert so both have the same power of 10. So if we have 10 to the 7th and 10 to the 9th, we can make this one 10 to the 7th by moving the decimal 2 times. Now, the idea is which direction we need to move the decimal. So the top one, right here, 10 to the 9th means we take this decimal point and we move it 9 times to the right. If I only want to move it 7 times to the right, it needs to start 2 places over. So it would be 34 times 10 to the 7th. So if we have 34 times 10 to the 7th, compared to 3.4 times 10 to the 7th, we can see that 34 is bigger. So when we compare, we would say that 3.4 times 10 to the 7th is less than 0.34 times 10 to the 9th. Let's do another way to do that. We could also put both of them in scientific notation. So this is the same problem, 3.4 times 10 to the 7th and 0.34 times 10 to the 9th. So the first one is already in scientific notation. The second one is not. This decimal point here means that, the exponent means I take this decimal point and I move it 9 spaces to the right. But in order for this to be in scientific notation, the decimal point has to be here. So I'm cutting off one of those places. So that means if in the red I had to move 9 places, then the blue only has to move 8 places. So it's 3.4 times 10 to the 8th power. Now if we have that, we can compare, since both of them are in scientific notation, we can compare the exponents and we still see that 10 to the 7th is smaller than 10 to the 8th, so that means this is a less than symbol in between. So that's the other option you have for comparing. So I'm going to stop this video now, and then we're going to have a different video that goes through more examples.